Here we have log x square minus y square upon x square plus y square base 10 is equal to 2. Then we have to find dy by dx. So first of all, let's get our equation. Here we have our function. So first of all, let's simplify this before we go for the steps of implicit function. To remove log, we can take anti-log both the side. So on right side, we will get x square minus y square upon x square plus y square is equal to, we will get 10 raised to 2, or we can say it become 100. Now for further simplification, let's take our denominator on the right side. So we will get x square minus y square is equal to 100 into x square plus y square. Now we are ready for following the steps because we get the simplest form of our implicit function. Our first step is differentiate both the sides with respect to x. So d by dx on left side, and 100 is constant, we don't have to worry about it. We just have to differentiate x square plus y square. So differentiation of x square will be 2x minus differentiation of y square, which is function of y, will be 2y dy by dx is equal to, your 100 is constant, we don't have to worry about it. Differentiation of x square will be 2x plus differentiation of y square will be 2y dy by dx. So let's simplify. After taking 2 common, on left hand side we will get x minus y dy by dx is equal to, on right hand side we will get 100x plus 100y dy by dx. So let's collect terms of dy by dx. Take y dy by dx on the right side, we will get 100y plus y. We are taking dy by dx common. Now let's take 100x on the left side. We will get x minus 1000x. So we can say on left side we will get minus 99x, and on right hand side we will get 101y dy by dx. So now we have to take the last step, which is, so we get dy by dx is equal to minus 99x upon 101y. So tada! Option A is your final answer. In this question, we have sec inverse 1 plus x upon 1 minus y is equal to a, and we have to find dy by dx. Let's get our function. First of all, let's simplify our implicit function. 1 plus x upon 1 minus y is equal to sec a. For further simplification, let's multiply 1 minus y on the right side. So we'll get 1 plus x is equal to sec a into 1 minus y. So here we get our simplified form. Now let's differentiate both the sides with respect to x. So we have to write down d by dx on both sides. So on left hand side we will get differentiation of 1 plus x will be 0 plus 1 is equal to, sec a is your constant, we don't have to worry about it. Differentiation of 1 minus y will be 0 minus dy by dx. So we can say dy by dx is equal to minus 1 upon sec a. But we need answer in terms of x and y. So we have to remove this sec a. So let's use equation number 1, and you will get minus of 1 plus x upon 1 minus y. Or we can say your dy by dx is simply y minus 1 upon x plus 1. Ta-da! Option A is your final answer. In this question, we have y is equal to under root of sin x plus y. Then we have to find out dy by dx. And for that, let's get our implicit function. First of all, we have to simplify this. And for that, let's take a square on both the sides. So we'll get y square is equal to sin x plus y. Now, our next step is, so let's differentiate both the sides with respect to x. Differentiation of y square will be 2y dy by dx is equal to differentiation of sin x is cos x plus differentiation of y will be dy by dx. Now, we have to collect all the terms of dy by dx on one side. So let's take this dy by dx on the left side. So you will get 2y dy by dx minus dy by dx is equal to cos x will be as it is. On left side, we can take dy by dx common. So we will get 2y minus 1 dy by dx is equal to cos x. So we just have to make dy by dx subjective. So we'll get dy by dx is equal to cos x upon 2y minus 1. Option A, the final answer. Ta-da! In this question, we have sin y plus e raised to minus x cos y is equal to e. Then we have to find out dy by dx at 1, pi point. So first of all, let's get our function, which is already in the simplest form. So let's directly differentiate on both the sides. So on left side, differentiation of sin y will be cos y dy by dx. Now, to differentiate second term, which is e raised to minus x cos y, you have to apply chain rule. E raised to is your outer function and minus x cos y is your inner function. So let's consider box around it. So we just have to differentiate e raised to box, which is simply e raised to box into d by of box. Within the box, we have minus x cos y, which are the product of minus x and cos y. To differentiate it, we have to apply multiplication rule. Minus x will be as it is. Differentiation of cos y will be minus sin y dy by dx plus your cos y will be as it is. Differentiation of minus x will be minus 1 is equal to, on right hand side, we just have to differentiate e, which is purely constant term. So it will be simply 0. Now let's simplify by opening all the brackets. Your cos y dy by dx will be as it is. We have to multiply e raised to minus x cos y within the bracket. So let's multiply with the first term. We will get e raised to minus x cos y into x sin y dy by dx minus multiply with the second term. We will get e raised to minus x cos y into cos y is equal to 0. Now let's move to the next step, in which we have to collect all the terms of dy by dx on the left side. So let's take dy by dx common from the first two terms. So you will get cos y plus e raised to minus x cos y x sin y, and the rest of the terms, or we can say terms without dy by dx, should be moved on the other side. So let's move this term on the right side. You will get plus e raised to minus x cos y into cos y. So finally, we get our dy by dx, which is equal to, in numerator we will get e raised to minus x cos y into cos y upon whole term which is within the multiplication of dy by dx will go in the denominator, but we need dy by dx at 1 pi point. So we have to put x comma y is equal to 1 comma pi. So first of all, let's get our dy by dx over here. Now put x is equal to 1 and y is equal to pi. So you will get your dy by dx at 1 comma pi point. E raised to minus x will be 1 and cos pi into cos pi upon cos pi plus e raised to minus of x and cos pi again into your x is 1 and sin pi. So let's simplify. Here we'll get e raised to minus 1, cos pi is minus 1, so we'll get e into your cos pi is again 1 upon minus 1 plus e raised to 1 into sin pi is your 0. So finally we will get your dy by dx at 1 comma pi point is equal to e. Tada! Option C is your final answer. Here we have x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. And we have to find dy by dx. This equation is in its simplest form. So let's move to the next step in which we have to differentiate both the sides. So differentiation of x raised to 2 by 3 will be 2 by 3 into x raised to 2 by 3 minus 1, or we can say minus 1 by 3, plus differentiation of y raised to 2 by 3 will be 2 by 3 y raised to minus 1 by 3 dot dy by dx is equal to differentiation of a raised to 2 by 3, simply 0, because a is a constant term. Now you have to make dy by dx subjective. So let's take term of x on the right side. So the only remaining term on the left side is 2 by 3 y raised to minus 1 by 3 dy by dx, and on right side minus 2 by 3 x raised to minus 1 by 3. So this 2 by 3 will cancel out, and you will get dy by dx minus x raised to minus 1 by 3 upon y raised to minus 1 by 3. Or we can say your dy by dx is simply minus y by x whole raised to 1 by 3. Option B is your final answer. Ta-da! In this question, we have a curve having equation root x plus root y is equal to 1. And we have to find dy by dx at 1 by 4, 1 by 4 point. So first of all, let's get our equation of curve. And here we have in the simplest form. So let's quickly move to the differentiation on both the sides. So differentiation of root x is simply 1 upon 2 root x plus differentiation of root y is 1 upon 2 root y into dy by dx. Differentiation of 1 is 0. So if we have to make dy by dx subjective, we should take 1 upon 2 root x on the right side. So we will get on left side, we will get 1 upon 2 root y dy by dx is equal to minus 1 upon 2 root x. So this 2 will cancel out, we will get dy by dx is equal to minus under root of y upon x. But we have to find dy by dx at 1 by 4 point. And for that, let's get our dy by dx first. Substitute the values of x and y as a 1 by 4. So here we'll get minus under root of 1 by 4 upon 1 by 4, which will give us minus 1 as a final answer. Option C is the answer. Ta-da! Here we have x is equal to y under root of 1 minus y square, and we have to find dy by dx. So first of all, let's get our equation, and here it is. To remove this under root, let's square both the sides. So on left side we'll get x is equal to y square 1 minus y square. For further simplification, we have to multiply y square within the bracket. So y square ones are y square minus y square into y square will give us y raised to 4. So we'll get function in its simplest form. Now let's differentiate both the sides with respect to x. So differentiation of x square will be 2x and differentiation of y square will be 2y dy by dx minus differentiation of y raised to 4 will be 4y cube dy by dx. So we can take 2y dy by dx common from the right hand side. So we will get 1 minus 2y square. On left hand side we have 2 and substitute the value of x, which is y under root of 1 minus y square. So here 2y will cancel out. We will get dy by dx is equal to under root of 1 minus y square upon 1 minus 2y square. Option C is your answer. Ta-da! In this question, we have 2 raised to x plus 2 raised to y is equal to 2 raised to x plus y. Then we have to find dy by dx. So first of all, let's get our equation, which is in the simplest form. So we are ready to differentiate on both the sides. On left side, differentiation of 2 raised to x is simply 2 raised to x into log 2 plus differentiation of 2 raised to y will be 2 raised to y log 2 into dy by dx is equal to, on right hand side we have 2 raised to x plus y. So we have to apply chain rule. 2 raised to is your outer function and x plus y is your inner function. So let's consider box around x plus y. So now we just have to differentiate 2 raised to box, which is 2 raised to box log 2 into d by dx of box. Within the box we have x plus y. So we just have to multiply differentiation of x plus y. Differentiation of x will be 1 plus differentiation of y will be dy by dx. So as you can see, we can take log 2 common from the entire equation. So on left side we will get 2 raised to x plus 2 raised to y dy by dx, and on the right hand side we have to multiply 2 raised to x plus y within the bracket. So 2 raised to x plus y ones are 2 raised to x plus y plus 2 raised to x plus y multiply with dy by dx will give us 2 raised to x plus y dy by dx. Now let's move to the next step. Collect all the terms of dy by dx on the right side and rest of the terms on left side. So let's get this 2 raised to xy on the left side. This 2 raised to x will be as it is. We get minus 2 raised to x plus y is equal to, now it's time to take 2 raised to y dy by dx on the right side. So we get 2 raised to x plus y dy by dx as it is minus 2 raised to y dy by dx. Now for further simplification, we can take 2 raised to x common from the right side. So we'll get 2 raised to x within the bracket 1 minus 2 raised to y. And from the right hand side, we can take 2 raised to y dy by dx common. So we'll get 2 raised to x minus 1. Now it's time to make dy by dx subjective. So we will get 2 raised to x upon 2 raised to y, or we can say 2 raised to x minus y, and 1 minus 2 raised to y upon 2 raised to x minus 1. Or we can say 2 raised to x minus y. By rearranging the term, we can say 2 raised to y minus 1 upon 1 minus 2 raised to x. Is your final answer, which is given in the option D. Ta-da! Here we have y is equal to sine inverse of sine alpha sine x upon 1 minus cos alpha sine x. And we have to find y dash 0. For simplification, let's take inverse function of sine inverse. So we will get sine y is equal to sine alpha sine x upon 1 minus cos alpha sine x. Now, for further simplification, let's get our denominator within the multiplication of sine y. So we will get sine y into 1 minus cos alpha sine x is equal to, on right hand side, sine alpha and sine x will be remaining terms. Now we are ready to differentiate both the side with respect to x. On left hand side, we have to apply multiplication rule. Let's say in first term, your sine y is as it is. We have to apply differentiation to the 1 minus cos alpha sine x, which is simply 0 minus cos alpha is constant. We don't have to worry about it. We just have to differentiate sine x, which will become cos x, plus in second term, your 1 minus cos alpha sine x will be as it is. We just have to differentiate sine y, which is simply cos y into dy by dx is equal to, on right hand side, your sine alpha is constant. We don't have to worry about it. We just have to differentiate sine x, which is nothing but cos x. So to get dy by dx, we just have to make it subjective, and for that we have to take our first term on the right hand side. So on left side, the only remaining term is 1 minus cos alpha sine x into cos y dy by dx, and on right hand side, your sine alpha cos x will be as it is, minus minus become plus sine y cos alpha cos x. Now it's time to make dy by dx subjective. So here we'll get dy by dx is equal to, your numerator will be this whole term. So let's get it over here, upon your denominator will be this term. So let's get it over here. So to get y dash 0, first of all we need to get the value of y at x is equal to 0. And for that we are going to use equation number 1. So let's get it over here and put x equal to 0. So we will get sine alpha sine x, or we can say sine 0, upon 1 minus cos alpha sine x, or we can say sine 0. The value of sine 0 is 0. So here we get sine y is equal to 0. Here we get, when x is equal to 0, the y will also 0. Let's use this condition to get y dash 0 by putting x is equal to 0 and y is equal to 0. So here we get y dash 0 is equal to sine alpha cos 0 plus sine 0 cos alpha cos 0 whole divided by 1 minus cos alpha sine 0 into cos 0. Sine alpha will be as it is, cos 0 is 1, plus sine 0 is 0, so whole term will be 0, upon 1 minus cos alpha into 0 is 0, and cos 0 is simply a 1. So finally we will get sine alpha as a y dash 0, which is given in option D. So, ta-da! D is your final answer. Here we have 2y is equal to sine inverse of x plus 5y. Then we have to find dx by dy. It is observable that your dx by dy should be purely function of y. So in this kind of a case, we have to make x subjective. And for that, initially, we have to write down our equation. So, as we plan, let's make x subjective. We can say, we get sine 2y is equal to x plus 5y. So let's make x subjective. So we'll get sine 2y minus 5y. Now, to get dx by dy, we have to differentiate with respect to y on both sides. So on left side, we will get dx by dy, and on right hand side, we have to differentiate sine 2y, which is simply cos 2y into coefficient of y, or we can say differentiation of 2y, which is 2, minus differentiation of 5y will be 5. Remember, we are differentiating with respect to y, so dy by dy is simply 1. Get dy by dx is equal to 2 cos 2y minus 5, which is given in option D. Ta-da! Here we have sin y is equal to x sin a plus y, and we have to find dy by dx. And from options, we can say dy by dx is purely function of y. So somehow we have to eliminate x. And for that, we have to make x subjective. So we'll get x is equal to sin y upon sin a plus y. And differentiate whole equation with respect to y on both sides. So on left side, we will get dx by dy, and on right hand side, you have to apply division rule. According to division rule, in first term, your denominator, or we can say sin a plus y, will be as it is. We have to differentiate your numerator, which is sin y, minus in second term, your sin y will be as it is. We have to differentiate sin a plus y upon sin a plus y the whole square. Now, let's simplify. In first term, your sin a plus y is as it is. Differentiation of sin y is cos y, minus sin y will be as it is. Differentiation of sin a plus y is cos a plus y, upon sin square a plus y will be as it is. Now, in numerator, we form sin alpha cos beta minus sin beta cos alpha, which is the formula of sin alpha minus beta, or we can say a plus y minus y, upon sin square a plus y will be as it is. So this y will cancel out, and we'll get dx by dy is equal to sin a upon sin square a plus y, or we can say your dy by dx is simply sin square a plus y upon sin a. Ta-da! This is your final answer, which is given in option C.